Hello, you're welcome. All right, so now the topic is functions. Okay, and we're going to be looking at examination questions. Okay, so we'll be solving some problems, and I have the very first question on the screen. Okay, I, I actually pasted it on the screen so that you will see it, then I'll solve it. I hope it is actually very clear enough, but if it is not, I'll still read it, right? So now the question goes like this. Let f, okay, be a function that maps R to R, okay, and is defined by f of x according to the question, okay. The function that maps R to R is defined by f of x, which is equal to 15x, 15x, then plus 7, all right. So now we are told that f is one-to-one and onto function, okay. So the question is give the formula for f inverse, okay, f inverse, and that will be f inverse of x, right? Now so this question is actually asking you to find the inverse of a function. Now I'm going to solve it and teach you how to find the inverse of a function, okay. Anytime you are being asked to find the inverse of a function, okay, it is you are invariably asked to reverse that function. Remember, a function have two variables, okay, the dependent variable and the independent variable, all right. So the dependent variable is the one that you see at the left hand side, which of course is x, while the independent variable is the f of x, which of course you can represent by y, okay. But that is by the way. So anytime you are being asked to find the inverse of a function, you are inversely asked to find the formula that reverses that function, okay, right? So in that particular formula actually reverses the function, makes the domain the codomain, and the codomain becomes the domain. But that's by the way, okay. I'm just going to show you a very simple step to which you could actually apply, okay, to find the inverse of a function. So now here, look at what you're going to do, right? So I'm looking for the inverse of a function. That's question mark. So for me to find the inverse of a function, what I would do is that I will replace the right hand side, the left hand side, which of course f of x, okay, by x. I will reverse it, okay, because every function is always expressed in terms of another variable. F of x is expressed in terms of x. So if I reverse it, okay, I will replace the f of x with x, all right. Then of course, wherever s was, I will now change it to f of s, but this time around now it becomes the f inverse of x, all right. So just that's exactly how you find the inverse of a function, okay. So all I just need to do is just for me to rearrange this equation and find um, f inverse, all right. So it's as simple as, okay, short, we do that, all right. It's simply, I'm going to take plus 7 to the other side of the equation, right. That's what that would be x plus 7 goes over, it becomes minus 7. Then of course, remember that's 15 attached to the f of 15 attached or multiplied to the f inverse of s. So the 15 comes, it becomes division. All right. So this is the formula for the inverse of this function. So that is just the simple step which you can take, okay. Reverse that particular equation, and of course you find the inverse. All right, so now let's get more question, okay. I'm gonna get another question. Okay, here I go. I'll pick a question and I will paste it on the screen, then I will solve it. Okay, so here we go. Here we go. Here we go. So I have another question, okay, on the screen. It goes like this. Let, okay, function f which maps R to R, okay, be defined as f of x. So the definition of this function is is equal to x squared minus x, right, then plus 2. All right, so this is the definition of the function, all right. So the question is we are being asked a part of the question for us to find the f of 3. So this is simple. So if we are finding f of 3, we are only replacing x, okay, by 3 in the function. So I'll simply replace 3. Okay, that'll be 3 square here, then minus 3. Any place I see s, I put 3. Okay, then plus 2. Right, so if I do this, this should be 9 minus 3 plus 2. So which of course, if we do this, I have 8. All right, so as simple as that. B part of the question, let's do B. Okay, so B, I'm asked to evaluate f of minus 3. Okay, then of course minus f of 2. All right, so know what we do. So we do f of minus 3. Wherever I see s, I put minus 3. So that'll be minus 3 squared, minus 3 squared, right? Then minus into minus 3. Don't forget to always apply brackets, okay? Anytime whatever you are substituting has minus, okay? Don't always apply brackets so that when you want to simplify, you will not end up having a wrong answer, right? So then plus 2. All right, so this is for f of minus 3. Then minus in brackets. Bracket is really very important, okay, because anytime you don't, okay, recognize the rule of, okay, applying brackets, you discover that most of the times when you use minus to multiply a bracket, okay, so minus has the ability of converting plus to minus and minus to plus. So if you don't apply bracket, you may not adhere to that rule, and at the end of the day, you will have a very wrong answer. So let's go there. So now I am actually doing f of 2. So where I see s, I'm putting 2, that will be 2 square, right? Minus 2, okay, then plus 2. All right, so here we go. So I now have minus 3 all square. Minus 3 all square, okay, is 9. Of course, minus 3 square is minus 3 times minus 3, okay, that's plus 9. Whenever you square a minus, it always give you plus, all right? Then minus into minus, minus times minus is plus. So I'm having plus 3 here, then plus 2, all right? We can put that in bracket. So this 2 square is 4, then minus 2 plus 2, that is 0, right? So I have, so this is gonna be equal to, this gives me 14, 14 minus 4. So the answer to this is 10. All right, so as simple as that. Let's go to the next C part of the question, okay? So we are being asked to find f of x minus 2. Okay, f of x minus 2. So let's do that. So any place I see x, I'm putting s minus 2. So that's gonna be x, okay, minus 2 all squared, right? Excuse me, s minus 2 all squared. Then of course minus, don't forget the brackets, okay, minus s minus 2, then plus 2. All right, so here we have to expand this bracket. Remember, s minus 2 all square is something as s minus 2 times s minus 2. Now the question is, how do you expand this? Okay, some of you know that if you want to expand this, simply go by, okay, doing this, okay, writing the brackets, multiplying the two brackets, okay, because it's all squared, okay. But sometimes if you want to go through this process, you discover that your solution becomes longer and ambiguous, okay, since you still have other part of the expression to simplify. So anytime you are being given a bracket to square, I will give you a shortcut to which you can use to square a bracket so that you will not go through the process of expansion, okay. So now let me give you the shortcut. Let's say you have a plus b, okay, and you're being asked to square this. Okay, simple. You just take the first element there, which is a, square it. Okay, then use the 2 and multiply a and b. All right, 2 times a b. Don't forget the plus there. Okay, that will give me plus 2ab. All right, then you now square the last, which of course is plus b. All right, that's b squared. So simple. Square the first element, use 2 to multiply the first and second element, then of course square the last element. So that is the simple step. So we apply that here now. So this is going to be equal to x squared, right? That's how we do it, x squared. Then I use 2 times x times minus 2 times x is 2x, okay? 2x multiplied by minus 2, that will give me minus 4x, right? Okay, so of course minus 2 square gives me plus 4. Okay, so minus into minus x here is minus x, right? Then minus into minus 2, that gives me plus 2, and plus 2. Okay, all right, so we can collect like terms together now, can't we? Yes, we can. S squared doesn't have any like terms, so I write it down. All right, minus 4x minus x gives me minus 5x if I'm not mistaken. All right, minus 5x, and of course plus 4 plus 2 plus 2, that gives me plus 8. So that is it. All right, let's proceed. Let's look at the next C part of the question. Actually, okay, this I've done the C part of the question. Right now I'm doing the, okay, f of y. F of y is just easy. Just, okay, replace x by y. Okay, of course that's gonna be y squared minus x, y squared minus y, sorry, then plus 2. Okay, so what do we have next? We have that's okay, E part of the question, f of x plus h minus f of x. All right, so I can actually clean up so that I will have space. Right, so let me clean up. All right, so okay, here we go. So I'm doing E part of the question, right? To evaluate f of x, right, plus h, all right, minus f of x. Okay, so here we go. So what does that mean? Any place I see s squared, I put s plus h, right? S squared, right? Then of course minus, I'm doing f of sh now. So any place I see x, remember our f of x. Not forget our f of x, okay? Our f of x still remains s squared, right? Minus x, then plus 2. Don't forget that, all right? So which is invariably now, if I'm doing s, f of s plus h, right? Any place I see s, I put this. So that's gonna be s plus h squared, okay, minus x plus h. All right. Then of course excuse me, plus 2. All right. So I'm done with f of s plus h. So I put that in a bracket, so in a block bracket, okay. Then minus, and I do f of x. F of s, I just write all this down, okay. So that'll be s squared, all right, minus x plus 2. Okay, so we are here. All right, let's expand. I've given you the shortcut, right? You square the first element, that's s squared, use 2 to multiply s and h. Okay, that will give me plus 2xh. Okay, then of course square the h, that gives h squared. Okay, so here we go to the next. All right, s, open this bracket, minus into s will give me minus s, minus into h gives me minus h. All right, then plus 2. Right, okay, so I am done with this. I am done with this. Then I have minus into s square will give me minus s square. Minus into minus x gives me plus x. That's minus into plus 2 gives me minus 2. Alright, so you know what we do? We collect like terms, right? S square. Okay, so let me collect like terms. S square minus s square. Okay, that gives me 0, right? So it's gone. Then of course I have 2sh. It doesn't have any like term, so I bring it down. I have plus h square, no like terms, so I bring it down. Minus s plus x is 0, so it's gone. Minus h doesn't have any like term, I bring it down. Then I have plus 2, right? Plus 2 minus 2, so that is gone. So this is the answer. Okay, I hope that is well understood. Now, F part of the questions. I'm being asked to find the F inverse, alright, of 10. So now this is inverse now. Remember we talked about inverse, right? So if I'm evaluating the F inverse of 10, that means I need to find the F inverse, the inverse of the function first, okay? F inverse of x first before I can now replace 10 to it, okay? So now don't forget my function, okay? Of course, f of x is s square, right? S square minus x, right? Then plus 2. Alright, so now remember what I told you about finding the inverse of a function. Simple, rearrange this. Where f of s is, replace it with x. Are you okay? Then of course the s itself now becomes the function, but it becomes the inverse of the function, okay? Don't forget that it is being squared, okay? So what I'm gonna do here, since I'm actually looking at something that is quadratic in nature, all right? Quadratic in nature. So instead of using f of x, okay, let me use y, but it's still the same thing because I need to actually factorize that, okay? So let me just do, say, okay, let's, so that you know what I'm doing, and let f inverse of x, okay, be equal to y. So that's what I'm doing here now. So that means for this now, remember I change it to y square, right? Then I change this to y plus 2. So we simply mean that if I find y, I'm invariably finding the f inverse of x, okay? Okay, so let's go there. So how do we actually solve it? See, this is quadratic, okay? The question is, how do you find the inverse of a quadratic function, as you can see here, okay? So now, to find the inverse of this quadratic function, please take note. Anytime it is a quadratic function that we want to find the inverse, okay, complete the square of that quadratic function, all right? Complete the square, then it is easy for you to find y. You know how to complete square, okay? For me to complete this square, this is a quadratic expression, y square minus y plus 2, okay? All I just need to do, I just add to both sides. Add, okay? Add half the coefficient of y, okay? Half the coefficient of y. The coefficient of y is add half square the coefficient of y. Add half square. The coefficient of y is actually minus 1, right? So that is half. Then of course you square it. Okay, I'm adding it to what? To both sides. So add half. Look, I find the coefficient of the y, okay? Y, or the, of course, the inverse of the function, okay? So find the coefficient. In this case, the coefficient is minus 1, okay? Do half of it. Half of minus 1 is 1 all over 2, right? Okay, half of whatever it is, then you now square it, all right? Square everything. So that's what you're going to add to both sides. And of course, if I do this, this will definitely, minus 1 square is 1, okay? And of course 2 square is 4. So 1 over 4. So I'm adding 1 over 4 to both sides of the equation. So I'm going to have x plus 1 over 4, because whatever you do to one side of the equation, you also do to the other side, all right? Is equal to y squared minus y, all right, plus 2, then plus 1 all over 4. All right. So how do we, with this now, this is, I've completed this square. This automatically has made this side of the expression a perfect square. I don't want to go through the process of actually talking about perfect square, but by completing the square, okay, it has made this a perfect square. So it simply means that if I should factorize this, I will simply have, okay, y, right, minus 1 all over 4. Sorry, y minus 1 over 2, okay? 1 over 2, not 1 over 4. 1 over 2 was what I actually squared, okay? Before I have 1 over 4, okay? All square. So please take note. By the time you complete the square, okay, you now do this. Okay, so don't worry, we'll definitely see a similar equation, similar problem, all right? So, or better still, when we do quadratic equation, you get to understand it better. All right, so that is, I've just completed the square, right? So by completing the square, remember looking for y. So what do I do? I have to square root both sides, right? So that I will eliminate this square, so that y will be free, okay, for me to make it the subject. So if I have to square root this side of the, okay, remember, if I square root the left hand side of this expression, it will be, I have to put plus or minus in front of it, okay? So x, the square root of x plus 1 over 4, right? Then of course, because of square cancel the square root, why I'm square rooting, so that I want to cancel this square, okay? So the square root of this other side, okay, will definitely cancel the square. Let's do that, okay? Okay, so square cancel square root. So now y is free to move, or y is free, okay, to be made the subject now. So in this case now, what I just have is just y minus 1 over 4, right? Okay, then of course plus or minus the square root of x plus 1 over 4. All right, so now I can now get my y now. So y is now going to be, minus goes on, it becomes plus, right? So that's plus 1 over 4, excuse me, 1 over 4, okay? 1 over 4, 1 over 2. Oh, please pardon me. Pardon the mistake. 1 over 2, okay? Okay, so it's only 1 over 4. This is 1 over 2. So this 1 over 2. Pardon the mistake. Alright? 1 all over 2. Here we go. Okay, so then plus or minus the square root of x plus 1 all over 4. That is it. We are done. All right, so this is the inverse, okay, of that particular function. So now remember, I just found the inverse, okay? That is not what I'm being asked to find, okay? So let me just take the inverse, okay? Let me take the inverse that I just did, okay? Bring it up here, okay, up. These are the process. I want to delete other parts, okay? I want to delete other parts so that I've got my inverse. Remember, I'm looking for the f inverse of 10, okay? That was what I was asked to find, okay? So the question was for me to actually evaluate f inverse of 10. So now this is of course my f inverse. All I need to do, just any place I see x, I'm putting 10. Okay, so that's gonna be 1 all over 2, all right, plus or minus the square root of 10, all right, plus 1 all over 4. Okay, so how do we do that? So this is gonna be f inverse of 10, right, is equal to 1 all over 2 plus or minus, if we simplify this fraction, LCM is 4, right? Okay, then of course 4 divided by this all over 1. 4 divided by 1 is 4. 4 times 10, right, is 40, right? Then of course 4 divided by 4 is 1. 1 times, so I have f inverse of 10, right, equal to 1 all over 2 plus or minus, if I find the square root of 4, I will have 2. Okay, so I have, then the upper part has 41 all over 2. Okay, if I simplify this, I have f inverse of 10 is gonna be equal to, the LCM here is 2 divided by 2 is 1. 1 times 1 is 1, plus or minus 2 divided by 2 is 1. 1 times the square root of 41 is square root of 41. Right, so definitely if you should solve this to the end, you discover that it will give you two values, all right, plus or minus, right? So that's, by the way, that is just that. Okay, so we'll look at f inverse of minus 5 is still the same process. It's still the same thing you're going to do. Okay, now okay, so we're going to pick on that question, okay, so that we'll just get a better understanding, right? So basically just go through this one more time. Let's look at more questions, all right? So here we go. Okay, so I bring another question to the screen. Okay, so it's not really clear, so I will read it and tell you exactly what it is. Okay, so now find the domains of the function with the following recipes. Okay, all right, so we are being asked to find the domain of this function. A is equal to the square root of s squared, okay, minus 1. Right, so now the domain of a function, okay, is actually the values of that particular variable, or the values of x, okay, that when I put it inside the function, it will make the function to be defined, okay, or even to make the function to give a real value. All right, okay, so now you discover that if I want to the only value of x, okay, discover that every value of s I put into this particular function definitely will make the function to be defined, okay, it will be real. So we are looking at the domain is just talking about all the value that you can put in this function that will make it to be defined, okay, not really make it to be defined. Okay, so now there's no value of s I put in this function from 1 to infinity. All right, so that means if I'm being asked to get the domain now, domain is simply, because if you are putting the domain, you are not, it's not just you have to include all the number. Okay, so I can simply say that, okay, the domain of this function is or the function is x, okay, such that, okay, x s is, and of course it's going to be all positive x. Yeah, okay, the domain of the function is going to be x such that negative infinity is less than x and s is actually less or equal to x. Okay, I know how you want to put it. S is okay, also negative infinity is less than x. So will I put it that way? Okay, just put it this way. No need to put just all the real numbers. Okay, is x such that x, okay, is a member of all real numbers. So what I'm trying to say is that okay, any value, because no all real numbers, okay, it's not just it's real numbers, talking about all the real number. Okay, so x actually can be any real number to make this function to be defined. So this is the domain. Okay, I hope that is understood. All right, let's actually go to the second part of the p. F of x is giving us 1 all over s squared minus 1. All right, so now the domain, of course the domain is talking about the value of x I can put in this function. Okay, that will make this function to be defined. Then of course, so if you look at this particular function, all the values of x are put in this function will definitely make this function to be defined. But what will make this function to be undefined is when x is equal to 1. How do I mean? When x is equal to 1, I have 1 square, okay, and the 1 square, which is 1. So 1 minus 1 gives me 0. One minus 1 gives me 0. Okay, so in a situation like this, I have that if s is equal to 1, then this particular fraction will not be defined. Why? Because the denominator of a fraction is not defined when the fraction is equal to 0. And when the fraction is equal to 0, so s will definitely make this fraction equal to 0. But apart from s being equal to 1, every other value of s, okay, every other value, real numbers, when I put it in x, it will be defined. So for me to write the domain the same way I actually wrote the other one, is going to be equal to, okay, a set of x, okay, a set of x, okay, such that x is a member of real numbers, all real numbers, okay, comma, but x shouldn't be equal to 1. Okay, so that is it, but s shouldn't be equal to 1. Okay, so this is how you write the domain. So you actually include all the numbers that will make the question defined, then exclude the one that will make it undefined. All right, so please take note of that. So that is just that for this question. Let's actually proceed to okay, get more questions to solve. I'll be picking questions. Okay, yeah, I have questions that I'm bringing to the screen. Alright, so here we go. So here I have, if f of x is equal to 2, okay, f of x is equal to 2x plus 1, okay, comma g of x is equal to s square plus 1. So the question is, find g of f of 0. So so before I find g of f of 0, okay, I need to find g of f of x. So g of, okay, g of f, okay, then of 0, or of x, because the x here, now I need to find that particular expression. Okay, This is what is known as composite function. Okay, why is it called composite function? It's a function of a function that combines, okay, g of x and f of s into one function. Okay, remember f of s is this, f of s is this, g of s is this. Okay, so I'm actually trying to superimpose, bringing, okay, taking a function into another function, right? So which simply means that, what this simply means that g, normally this was supposed to be g of x, okay, but now it is now g of f. Instead of being g of x, okay, it is now going to be g of f of x. So that means in place of x of the g, f is actually replacing it. Okay, so this simply means that this is something as g. This is something as saying, okay, g, right, in the place of x. Are you okay? F function of s now replaces it. That's exactly what it means. So that's what g of f is. Okay, so it is a function of g where f of s is replacing the x. Okay, so please take note of that. So how do we do that? All right, so let's evaluate that. So this is going to be equal to, remember, this is my g of s, okay, which is defined as s squared plus 1. So which simply means that if f of s is replacing this, okay, any place I see s square, any place I see s, okay, I'm putting the value of f of s, and this is the value of f of s. Okay, so that's going to give me, okay, so 2x, right, plus 1. That's f of s, remember. Okay, don't forget that it is squared. All right, then plus 1. All right, so now if we have this, remember our shortcut to squaring, okay, to squaring a bracket, a square 2s. 2s square will give me 4s squared. When I square 2, that's 4. Okay, when I square s, I have s squared. Then I carry 2 to multiply. 2 times 2s, that's 4s. 4s times 1 is 4. So I have is 4s, right? All right, then of course I square 1 plus 1 square. If I square 1, I still have 1. All right, then I have plus 1. So if I should do this, I have, this is gonna give me 4x, right? 4s square minus 4s, right? Let me write that below here, right? This will give me 4s square plus 4x, then plus 2. All right, so now that is the formula. Okay, so after we've gotten the formula, now we can actually we can express it, okay, in terms of g of f of 0, okay, replacing s by 0. So we simply mean that the g of f then of 0, okay, is gotten when I actually put 0 into this function. That will be 4 into 0 square, right? Then of course plus 4 into 0, then plus 2. Okay, that's 0 square is still zeros. 4 times 0 is 0. This is 0. Everything here is 0. So I'm only left with 2. Okay, let's go to the next. So the next is we are asked to find f of g, all right, of 2. Okay, but then I have to find the formula first. You know that, right? So f of g is something as saying f of x, okay, but the x now is being replaced by g of x. Okay, so please take note of that. So this is gonna be equal to, I go to the so what is, first of all, what is my f of x? Okay, as you can see, my f of x is 2s plus 1. So any place I see s, I replace it by the value of g. Okay, so that's gonna be 2x. So I replace it by the value of g. What's my value of g? That's s squared plus 1, right? All right, so all right, then of course plus 1. Okay, so let's open this bracket. This is gonna be 2s squared, 2 times s squared, that will be 2 squared, 2 times plus 1, that's plus 2, right? And plus 1. So if I do this, I have 2s squared. 2 plus 1, that's plus 3. Alright, so yeah, we have that as this. That is our formula, right? Then of course we can now put the value, right? Put the values. So that's gonna be 2 into 2 square root plus 3. Alright, here we go. 4 times 2, that's 8 plus 3, right? And that's 12. Is it 12? Yeah. Oh, it's 11. Okay, so as simple as that, I'm very sure that you'll be able to do this, right? Okay, so is there any other thing that we ought to... Okay, so thank you. Let's do one last question, okay? So basically, these are the things that you should practice, okay? It will definitely help you in the forthcoming examination. All right, okay, here we go. I bring it to this screen. Yep. So the question is, find the domain and the range of each of the following function. Of course, you know how we find domain, okay? So we definitely find the values, include the values, okay? List out the sets of the value of x that will actually make that function to be defined. So if I should list out the set that will make this function to be defined, okay? All right? I will discover that this function, yes, it can be defined, all right, with all values of x, but it becomes complex, okay? And of course, complex number, all right, complex number is still it's also part of a number, right? So in this case, I will simply say that, okay, for this function to be defined, okay, my domain, all right, marks all the list out all the values of x, okay, such that x, all right, x belongs to are members of all real numbers, okay? So definitely, though x, okay, if x is actually negative, this function will definitely be give a negative value, right? Okay, I will come back to this question, okay? So but let's actually work on the second one, this a part of the question, right? Okay, which number? Let me just a part of the question, right? Then the b part, right? I have y equal to x squared, right? Minus 4 all over s squared minus 9, okay? So remember, this now is a fraction, okay? You know how we used to, if you are finding the domain of a function that has the form of a fraction, okay, we list all the value of the x, but exclude the one that makes the denominator of the fraction to be equal to 0, right? So what makes the denominator of this fraction to be equal to 0 is when I put s to be 3. If s is equal to 3, okay, 3 squared is 9, and 9 minus 9 will be 0, okay? So my domain, okay, as usual, definitely is a set, excuse me, okay, it's a set that lists, it's a set of x, okay, such that x, okay, is a member, s must belong to member, there must be a real number, okay, member of real numbers, okay, but x shouldn't be equal to 0, shouldn't be equal to 3, okay, 3 is excluded, as simple as that. And of course, finally, the last but not the least, okay, I have the c part of the question, okay, so which of course, that's y y is equal to 1 all over, okay, the square root of x squared minus x. Okay, discover that in this case, if I put x to be 1, right, this will be 1 minus 1, and of course it will make this square root to be 0. Square root of 0 is still 0. Okay, so s equal to 1 is excluded. Okay, so my domain, all right, is equal to the list. The what I want to find out, that's I must, yes, and must have actually forgotten that is a complex number being part of what makes a function to be, okay, to be defined. But let's just go by what we know, okay, what already the one that actually makes this fraction, okay, the value of x that makes this fraction to be 0. Let's exclude that one, okay. So I can simply say that, okay, the domain of this function is all value of x such that x, okay, belongs to all, okay, must be a real number, but x shouldn't be equal to 1, okay. So what they call this set builder, okay, I'm using a set builder to actually build this set, right? So that is it. That is it. Okay. So if there are other information, okay, if there's some other things I need to actually correct, talk about, then of course there's gonna be another video. Okay. So basically, I'm actually bringing your attention to the certain question, okay, that you need to practice, and of course how you tackle those questions, because definitely such question will actually come out in your exams. All right. So let's see you in our next video. Thank you very much.